Hi, I'm Vadim Orlov, CTO and co-founder of DataForge. Today I would like to talk to you about refreshing data in a lakehouse. Refresh is an integral part of any data pipeline. Its main purpose is to consolidate multiple batches or streams of data, remove duplicate records, and expose the latest gold version of a dataset to consumers. Refresh also carries multiple important auxiliary features, such as capturing change history in the data, enabling incremental processing, providing observability metrics, and many others. I detail them in my linked blog. As usual, I recommend that you read it first, as it will help you get better context for this video. Previously, I reviewed the most common incremental data refresh pattern for datasets with natural primary key. You can find the link in the blog as well. In real life, however, many datasets either don't have primary keys or it's just impractical to use them for refresh. So today I'll review alternative refresh patterns available in DataForge Cloud and explain how to configure and use them. We will also talk about typical use cases for each pattern. Let's start with probably the most common pattern and which you are very familiar with. In DataForge, it's called full refresh, and it replaces the entire data set with the last received batch. It is also known as truncate reload pattern. So let's get started. All right, let's create a new source. Call it orders. We're going to pull data from the SQL Server connection using this query and save it, pull the data. Now, while it's pulling, I'm going to go back to the settings. So as you notice, data refresh is defaulted to the full here, which is very common when you first pull the data. You don't know what schema it contains, you don't know the columns, etc. So majority of our users just use this first, just to get themselves familiar with the schema. So now that we loaded, you can see the columns. Now you can create the rules, relations, etc., configure transformations. But full refresh is typically used at the beginning of the development. It's also very convenient for small and medium-sized data sets. I would say maybe up to 1 gig in size. It's just faster in a lot of cases, just to replace the data set versus like configuring the refresh pattern. All right, so let's jump into the inputs page, and you see that we created a new batch. We loaded 31,000 records, and our data shows up here. You can see all the columns. So now let's go to the SQL Server, and I'm going to simulate the change here. So as you can see, my store proc added 9 rows and I updated 4 rows. Okay, so let's go and pull another batch. And once it gets in, I should see 9 more rows coming. Okay, so it's done. Yeah, you can see that there's 9 additional rows came in. So once it finishes, we're gonna go to the data view and look at the data. If I sort on modified date, you can see these are the 14 rows which I just changed. They're sitting right here at the top. Okay, so pretty straightforward. So what you can do here though is you can go back to the previous versions, right? Because we keep history of all the previous batches, right? So let's say you decided to go back and reset to this batch. So all you need to do is just click this, and it essentially resets the data set to the previous batch. And if we look at the row counts now, you can see that it's back to my original row count. Okay, so it's pretty straightforward. Like I said, typical use case is initial development, but also suitable for small to medium-sized data sets. The next pattern we're going to talk about, we call it none in DataForge Cloud, but essentially it's just appending the data appending the batch to the data set, right? Every time you receive new batch, you just append it. You don't do anything with previous data that contains in the data set. So we're going to talk in a minute how you about typical use case, but for now, let's just we're staying on the same source. So what I'm going to do, I'm going to switch full to what we call none, right? And again, you can see the detailed description here. Is data changes are not tracked, and data is not refreshed. So it's essentially a pending append only parent. Okay, so let's call it switch to none. And this is, as you notice, DataForge Cloud gives you ability to switch refresh parent on the fly on any source. So very convenient. Once you do this, its system forces you to reset change data capture process. So because now it needs to recalculate the refresh. So this doesn't pull data. So I just using the data that's already in my data lake. And now it just recalculates. So essentially it's running the change data capture process again and calculating the new version of the gold data set using my new refresh pattern. So once it finishes, I'll show you what it looks like. So same record counts as previously, but the key difference here is now if you look at the total record count in the gold layer, now it's just the sum of two batches, right? You have 63,000 rows, which is sum of these two numbers, right? The use case for the non-refresh is when you are able to extract the data incrementally from your source systems. For example, when you're receiving the files which contain only incremental changes. One feature that makes it a lot more useful is ability to track watermark and apply it to get those incremental changes in ingestion. Okay, so I'm going to demonstrate that next. Let's delete the data here and then go to settings, and I'm going to add a couple of parameters here. So in the capture data changes, there are two settings here, watermark column, and I'm going to configure modified date column as our watermark. And for initial value, I'm going to set it to something really old. Okay, and I'll explain in a second what it does. So I'm going to add where clause to this query. So save and pull the data. So while it's running, let me explain what this does. So this column tells the system to track maximum value of this. We also call it watermark, right? So for the data set that has been successfully loaded, and then each next ingestion will filter the records which have greater value than the last unmodified date that was previously loaded successfully. Okay, so this really helps you to achieve the incremental ingestion, and so we loaded the first data set, right? It has everything. Then I'm going to go to my SQL server, change the data again. So you can see I added 2 rows, updated 5. So let's see what happens when I pull data again. So I'm expecting to see 7 records in this batch. Because yeah, right, you see 7 records, and the reason why is if I look at the logs, and in the logs we print the details of the query that was evaluated. So you can see my query is has this where clause. So this substitutes the watermark column value and pushes it down to the source system. So now I'm extracting only those records which have changed. Okay. So very useful feature. We had this for pretty much all refresh patterns except full. You can use this pattern for to track dates, or in this case, it doesn't have to be a date. It can be any column, and like integer or long, and really gives you ability to do this incremental ingest. Moving on to the next pattern, we call it timestamp, and it's really useful when you deal with time series data. It essentially allows you to replace the whole intervals of time series, and time series data typically doesn't have primary key. So one requirement for this refresh pattern is that the data you receive in each batch needs to be continuous. So and I'll explain in a second what that means. So let's create a new source. I'm gonna use meter data for this. So which includes readings from meters, from smart meters, and this will be the file source. I'm receiving files. So let's use this bucket, and here I need to specify the file mask. So I'm going to pull it from this folder. My format is CSV, so it's delimited, and for the data refresh here, I'm going to select timestamp, and for the date column, I'm going to specify TS is a column that has timestamp of the reading, and that's all I need. I'm going to save. Oh, one other thing is I'm going to switch it to Watcher, so this source will track anytime you drop the file to the folder, it will immediately initiate the ingestion. Save this. Now this is my folder, so I'm just going to select the file, first file. These are my files, so you can see they have dates. So I'm going to start with the first one, drop it here, load, and now my source should pick it up. Okay, the data is loaded, so let's take a glance at the data set. Like I said, it's a smart meter readings. There's timestamp column, which time of the reading, meter ID, name of the parameter, and the value for the reading. Okay, pretty simple. So one important thing, as I mentioned earlier, the timestamps need to be continuous. So what it means is you can see if I sort them, starts with January 1st, midnight, and then you can see we get readings every 2 hours. So and the finishing last reading is January 31st at 22 hours. So the period is continuous and we can see that here in our effective record count. If we click, you can see that because I selected the refresh type to be time series, it identified my what we call transaction range, starting on January 1st and going through January 31st, and my effective range is the same because now my I only have single batch, right? And these are my total records, and you will see how this changes as I ingest more files. Okay, right, let's upload the next file. My upload window, this is my file, starting with January 2nd, sorry, February 1st. Upload this, and it should get picked up momentarily. Yeah, you can see it's already started. So while it's running, I'm gonna show you a quick diagram I made. So we just loaded this first batch right here, right? So which has a range of timestamps from January 1st to January 31st. And this on the right hand side, you see how it's being represented in the consolidated or gold data set. Okay, so it's basically first batch is just a copy. What we're doing now is we're loading that second data set, the second batch, which spans basically a month of February. Okay, and what we expect to see, it's just going to append that February batch to the goal data set. So let's see how this plays out. So looking, so it just finished loading. So effective record count, you can see that it's between February 1st and February 29th. So everything looks good. Okay. Now let's load the third file. My upload window. This is my file, starting with January 2nd. Sorry, February 1st. Upload this, and it should get picked up momentarily. Yeah, you can see it's already started. So while it's running, I'm gonna show you a quick diagram I made. So we just loaded this first batch right here, right? So which has a range of timestamps from January 1st to January 31st. And this, on the right hand side, you see how it's being represented in the consolidated or gold data set. Okay, so it's basically first batch is just a copy. What we're doing now is we're loading that second data set, the second batch, which spans basically a month of February. Okay, and what we expect to see, it's just gonna append that February batch to the gold data set. So let's see how this plays out. So looking, so it just finished loading. So effective record count, you can see that it's between February 1st and February 29th. So everything looks good. Okay. Now let's load the third file. So I'm going to open the window here and drop that file here. Click upload. While it's running, I'm going to show you what we're doing on the diagram. So we are loading this page number 3 here. And that's different because you can see the dates are overlap, right? So it starts with February 15th and goes through the end of month, right? So what we expect to happen is this third batch is going to override gold data set for this interval, right? That's why continuous is really important here, because essentially it's going to replace everything in that gold data set for between those two timestamps. Okay, so if we look at the process now, so we can see that first of all, effective ranges kind of go from 15 to 29, but we also see that effective record count changed in my second batch. You can see it's now smaller, and that's because it was overwritten by my last batch. So what happened is, again, we overwrote this interval here. It was replaced by the data in batch 3. Okay, and let's do a couple more drops. So we'll go to let's drop these 2 files and upload. And again, while it's running, I'll show you what we expect. So we are loading batch number 4, which will do 2 things. We expect this to override data from the batch 3, right? Because it has start date of 225 here. And it will also add this chunk of data going into March. So from February 25 to February 29, it will replace data which was created by batch 3. And then it will add this chunk of data here, which extends into March. Okay, and then batch 5 is again a little bit different. So what that will do, you can see it starts with January and goes for February. It basically replaces an earlier data set which was created by batches 1 and 2. So it will override a range from January 10th through end of February, which was created by batch 1, and then it will also replace first 5 days of February here, which was written by batch 2. So if we look at the inputs page now, you can see that numbers have been reduced, right? So for the batches 1 and 2, effective ranges are smaller. And if we look at the current effective ranges, so batch 1 now only carries data from January 1st through January 9th, end of the day, right? So, which is exactly what we expect, right? So this is what it is, okay? And then batch 2 has data from February 5th through February 14th, and again, it's right here. And batch 3, sorry, batch 3 has effective range of 15 through 24, right there. And batch 5 has, sorry, batch 4 is 25 through 15. And batch 4 is essentially right here, okay? And the last batch which we loaded was batch 5. This one has effective range of January 10th through February 5th. So which is right here, okay? So essentially, this allows you to load data in any order, and the last batch will override the range that it represents, so replacing the data. So really, for you, as far as use case goes, helps you to, when you're receiving files, especially out of kind of order, and when you need to update readings. So the readings data is often corrected, so you get initial readings, and they need to be corrected and reloaded for some reason. So this is really helpful because it allows you to replace those intervals very efficiently. The next refresh pattern is called sequence, and it's very similar to timestamp. The only difference is instead of timestamp columns, you specify one or more numeric columns, could be integers or big ints. And this is, otherwise it works identical. It's just based on calculating the ranges. And it really is useful when you're receiving the data from sensors. So sensor data, they have those sequence numbers very often. And so, yeah, so that's basically the only difference. Otherwise, it works identical. All right, so the next pattern I'm gonna look before we jump into that. So so far what we covered is we looked at the full key is something I reviewed in my last video and blog. So see link in the description if you missed that. Then none sequence, we talk about none, talk about timestamp and sequence, and the last one I'm going to focus is in custom. So custom is essentially anything that does not fit in one of those 5 patterns, right? Before we jump there, I'm going to quickly open the last file I loaded and show you. Yeah, so this is the last file we loaded, batch 5. And this CSV data, one thing I instantly recognize is the meter IDs only include 2 and 3, right? Well, all other files have kind of meters for going 1 through 5. This file only has data for two meters, okay? And so what happened when I overrode, my last batch overrode data from these 2 previous batches. So it's not entirely correct because now I wiped out data from meters 1, 4, and 5. Okay, so let's use custom refresh and to fix this. So, and again, you can change refresh type anytime for any source. So I'm going to switch it to custom here. And the way custom refresh works, it's you're basically specifying delete query. So the pattern is first you delete the data from your goal data set using this query, and query is just a column pure function. Essentially, it's like Boolean where clause, if you will. All right, that you can reference your gold hub table, and you can reference your batch. And I'll show you in a second how this works. Okay, so my delete query is going to be this. So let me kind of unwrap this for you. So it's an exist clause. So SQL expression I'm sure you're familiar with. So input references the current batch I received, and this references the current hub table. So what this does, it deletes records in the gold data set that match this condition. And to drill down on that, it's if it's for the matching meter, all right, matching meter ID, if timestamp exists in a hub table, which is between min and max of timestamp value that are contained in the batch, we're going to delete this, right? And so, and again, pattern is we delete data first from the hub table, and then we append current batch, which optionally you can also filter this. I'll show this a little bit later. Okay, so I'm going to save this and kick off reset CDC. So what it will do, it's again using the files we previously ingested. It will just reapply the refresh settings for each of those batches, and then we'll see how this changes manifested. So for batches 1 through 4, it's going to be identical logic to the time series refresh, because essentially each subsequent batch will delete time ranges where it finds matches in the batch, right? And because each batch has meter numbers 1 through 5, it will just delete this. So up to the batch 4, we pretty much expect the same results, right? But starting with batch 5, we're going to see the difference, okay? So what we expect to happen is batch 5, because it only contains data from meters 2 and 3, right? It's going to selectively delete that data for that range, right? So what's going to happen is it will the data for meters 2 and 3 will be replaced by the data from batch 5 right here, okay? But data from other meters 1, 4, and 5 will remain unchanged, okay? And if you look at the numbers here, right, so this, you can see how the numbers are different. So now we still display effective record count, but if you look at the, and you can see it's higher than it was before, because now we retain the data from meters 1, 4, and 5, okay? So really powerful pattern. It gives you ability pretty much to implement your own refresh style. If anything doesn't fit into one of the predefined patterns, you're basically specifying this criteria, and you can remove any records as you define this. You can also, there is one other parameter here, we call it append filter, right? You can also filter what gets appended from the batch, right? So this, again, use case for this is when you have delete markers coming in from the source, you can actually filter those out. So you can apply those delete markers to delete the data in the destination, in the hub layer, but you want to filter them out so they don't kind of propagate to the gold data set, okay? And like I mentioned, so watermark columns are applicable to both, to all refresh styles, okay? To summarize, we looked at the 6 different refresh patterns available on DataForge Cloud, which are easily configured for the UI parameters as demonstrated. So the key one I reviewed in the earlier video, see the link in the description. It's kind of standard slowly changing dimension type 1, 2 pattern where dataset has a primary key. The full one we looked at first, so really helpful when you're loading initial data set, just to get familiar with the data. Also very helpful for small data sets. None works really well when you're already receiving incremental data, but all refresh types, as I mentioned, have the ability to use watermarks, so you can facilitate incremental ingestions. Timestamp and sequence very helpful when dealing with time series data and also data coming from sensors. And the custom refresh is kind of the most flexible option. So it gives you ability to specify one or two column pure functions to facilitate the refresh process. Okay. Few other things I wanted to mention, and again, I can refer you to the blog, which has all the details. So there are several secondary subsystems available in DataForge Cloud, which are connected to the refresh. First is capturing historic data. It kind of works for all refresh types a little bit differently, so it's described here in the blog. We also do the processing atomically, so it either passes or fails, and it never leaves your data set in the inconsistent state. Incremental processing we reviewed. Reprocessing, I demonstrated how we can switch parents at any time. Very handy when you already have a source built with rules and transformations. You can just change the refresh type and then push it to production. Unload and reload, we also show you how deleting the source data is easy, and you can just do it with a few clicks. And finally, the observability metrics, all the different record counts, timestamps, effective records, really helpful when you are monitoring the data loads and observing the data. Okay. So hopefully you find this helpful. Please check our website. We have 30 days trial. Sign up, and always looking for your feedback. Thank you.